everyone. I'm Yongdae from KAIST. My talk will be completely technical, like different from David's. So I'll be talking about how to evaluate blockchains, theoretically and experimentally. So let me briefly introduce myself. I'm a professor at KAIST, and usually what I do is I break things like hacking self-driving cars, drones, and hacking cellular networks. But also, and because I've been writing papers about breaking these kind of things. I mean, I've been on the international media quite a bit. But actually, before I came to Korea in 2012, actually I've been doing some of the peer-to-peer stuff. For example, between 2008 and 2010, actually I showed that you can shut down whole email network, if you know email, eDonkey network using a single machine. And basically they had to patch their system because of our attack. And probably I think last year I started working on the blockchain, and we had a paper in ACMCCS, which is a top security conference, and we are writing more papers about it. So yeah, I mean, blockchain is booming, yeah, and we had a crypto investment war at the end of last year, and now the price is going down. And also a lot of people are interested in designing third generation blockchains, right? And there are a huge number of ICOs, and many business models are coming up. And I believe most of you are designing, implementing, running, funding blockchain or business model using blockchain, right? But do you know how good yours compare with others? I think many of the developers just develop their system without knowing actually how good your system is compared to others. So there are other questions. I mean, on individual blockchains, someone said, oh, A has 10,000 TPS, or B said B is secure, C tolerates random network failures, D solves trilemma, or B's block size is 8 megabyte to improve performance. Or there are macro questions on set of blockchains, such that a decentralization versus incentivization, right? And Vitalik Buterin talked about radical decentralization, and Silvio Micali at MIT talked about incentivization is the hardest thing to do, right? And there are other debates like POS versus DPoS. There have been many debates, and we don't know exactly how they are compared to each other. So for now, right, I'm not designing any new protocols. But instead of developing, gazillion, new protocols, can we actually theoretically and experimentally evaluate a set of blockchains? That's my take. So why we can do technical evaluation? Of course, David can do, as a startup, if a blockchain is going to, be good, he can do it, right? Based on, his experience. But I think blockchain has another opportunity because we can do technical evaluation of the blockchain because there is a white paper and academic paper. You can do theoretical analysis, and you understand what kind of business model they have. And also, most of the blockchains are open source. And also, in case of public blockchain, actually, you can join the public blockchain and you can measure things. But in reality, actually, because early phase funding is important, and VCs basically believe people, I think that's all people do. And there's a huge gap between the theory and practice. For example, in the design phase, some blockchain looks really great, but at the end, what you have in the deployment actually looks completely different. And there is no actually blockchain evaluation technology. So I give you one example, what we did for actually measurement-based study. And so I think as you all know about Stellar Lumens, which is the top 6 coins in the world, designed by respected professor at Stanford, David Meziers. And Stellar uses something called, FBA, Federated Byzantine Agreement. And we did some measurement on stellar lumens, and we discovered that there are about 3 nodes in stellar network. And if you kill 2 out of 3 nodes, the stellar blockchain will be completely not working. It is completely centralized system, and if you kill 2 out of 3 nodes, then basically stellar network is not going to work. And if you analyze actually why it happened, but if you look at the white paper, actually it doesn't look like that. Okay? And it is actually, during the implementation and also during the deployment, they have relaxed some of the requirements, and that made all these disaster-like things, right? So using the measurement study, actually, you can analyze problems. And I think people have been lacking on this. And the second thing I'm going to talk about today is BUIDL, which is some kind of blockchain evaluation platform we are building with my students. So one thing I want to say is that, these are research papers, like double spending paper, Eclipse attacks, Zeus did smart contract analysis. And all these famous research papers published in top conferences. It's quite strange. One thing quite strange is that all these papers, research papers, are only about Bitcoin and Ethereum. Why? Why do we have only papers about Bitcoin and Ethereum? I think there are a few reasons. First, these two are only fixed ones, and all the others are kind of being developed, right? And the other thing is that, and then you can think, oh, if others could be fixed, then the similar vulnerabilities will appear in other blockchains too, right? So, and another thing is that Bitcoin and smart contract is kind of fixed, right? And let me think. Yeah. So if there is some kind of so it is fixed, and also there's a standardized platform, right? So in case of smart contract, we can use Solidity EVM to evaluate blockchains, right? But can we evaluate consensus algorithms or consensus implementations? How do we implement? Actually, if you look at those implementations, they are all different. Okay? Then it's very difficult to know actually how good they are. So I think blockchain needs evaluation. But there are, quite a bit of difficulties existing in blockchain evaluations. So what's happening? So there are a lot of unpredictability in the peer-to-peer network. And basically, peer-to-peer network development itself is not standardized. And there is no single metrics, TPS, TPS, and all these different metrics people are getting. And decentralization, security, scalability, we don't know how to measure all these things. And if there is a blockchain evaluation platform, technical, it should be cost-effective and scalable, and it should be reproducible in terms of evaluation, and should be standardized for giving fair comparison among different consensus and blockchains. So we are designing some platform called BUIDL. It is a scalable, reproducible, standardized evaluation platform for blockchain, and we try to reduce the gap between the theory and deployed networks. And there are 3 reasons we are actually developing BUIDL. For developers, we want rapid and stable development with efficient and effective and maybe robustness testing. For venture capitalists or exchanges, they can actually concrete in terms of technical value. Evaluation could be possible using such kind of evaluation. And also the last point is for students. I don't know how many students here are, but actually none of the students actually have built any of the consensus algorithms before actually they actually start working in the blockchain companies, right? Do we have I mean, if you take operating system class, then probably there is a, like skeleton OS like nachos, but there is nothing like that for blockchain. So what we do is basically, BLIP is some kind of emulation platform on top of single host. So you can run 1,000 nodes in a single host, okay? And there is a very famous simulator called Shadow, which is a paper I co-advised with. And Shadow was originally developed for Tor emulation. And Shadow has shown that you can actually embed network information and all those kind of things. And the behaviors of the Tor network versus Shadow is actually very, very similar. And you can actually plug in Bitcoin and all those things pretty well. And basically we are doing some kind of network level virtualization that you can actually implement the system. I mean, yeah, I can get into details. So BLIP has some kind of hierarchical structure. And this is a typical, blockchain. And we have a peer, and we have some kind of traffic generator, because this is an emulator, right? So we have a shadow simulator at the bottom, where we can shadowify the sockets, threads, and cryptography. Basically, we already implemented that. And so imagine this, like you have a single host, okay? And all your network I/O is replaced with memory I/O. And you can run 1,000 Bitcoin node on a single host. And you can actually replace some of your gossip algorithm with something else. And you can have different PBFT or POW and POS, and all those things could be implemented in a single host. Okay? So instead of, in addition to the manual traffic generator, we are also implementing manual network event generator that can cause network failures or random network partitions and all those things. And so we already implemented Bitcoin on a single machine. Intel i7 is just a 16 gigabit of memory, and we are emulating Bitcoin. And it can scale up to 1,000 nodes and 290 seconds. And I show you live demo using our web interface. 데모 좀 보여주세요. Yeah, so this is actually single node starts. So right now we are running with a 500 node. And right now 500 nodes are actually forming peer-to-peer networks. And you have to be waiting because they have to set up. And then now blocks are being generated. And so the block generation time is 4 seconds instead of 10 minutes here. And because it's 4 seconds, it's generating actually more forks, right? And the time on the right is actually real time, and time on the left is actually virtual time. So every 4 seconds, the blocks are being generated, and it's causing faults sometimes. It's running well, okay? This is actually different from the simulation. This is actually Bitcoin client you can run on Amazon as a separate node. But you can also run this on a single machine, and where in the networking layer, you can embed arbitrary networking events. And actually, we are thinking about all these different directions you can go, to do actual system testing as well as the performance comparison. And I've been talking to many of the I've been talking to many of the developers, many of the blockchain developers. They want some kind of testing environment. And yeah. And if you use Shadow, you can implement peer-to-peer system pretty well. So one of the difficulties, I mean, there are some, actually quite a bit of challenges. So many of the blockchain assumes, I mean, implementation assumes a single host. For example, in case of Bitcoin, every node has a different storage, right? Separate, Buckley DB, right? And if it is running on a single machine, then all these Buckley DBs will be replicated, and that becomes crazy, right? The storage is going to increase crazily, right? And the mining is also complicated. Should we do hashes? Or we can replace it to something else? And, right, so there are, I mean, if you already have a good running blockchain, shadow find takes some time actually, and we try to make it better in the sense that, right now we need some kind of modification at the source code level, but our actually long-term goal is without actually modifying the source code, if you can hijack messages in the kernel, then we can work with any of the binaries. So that's actually our long-term goal. And we want to do performance optimization. Right now, it is running actually pretty fast. 1,000 Bitcoin node, actually it doesn't take that much time. For like 300-minute words, you can run it in 20 seconds. So that's very fast. You can actually emulate. But if you want to scale up to 20,000 or something like that, you need some kind of horizontal scaling as well. And we want to build, more blockchains. And the students, I mean, it takes time for them to learn. But at least some of the parts are being implemented with undergrad. I think it's pretty good already. So I don't know if it is clear, but I mean, for developers, I think you can actually do basic testing. And also you can do stress testing, and you can do evaluation and causing faults, and how robust is your design against the code. And also I think VCs and SECs and DACs, you can do some kind of standardized evaluation, and you can do also stress testing. And basically we are talking about many different directions, and for students, actually, they can have distributed system or blockchain development experience in a single host. That saves huge amount of money. Instead of running many Amazon nodes, actually, you can do most of your early work on this platform right now. The last piece I'm going to talk about, how much time? I didn't get, oh, okay. 1 minute? 10? Okay. She was like upside down. Okay, so the last piece I'm going to talk about is more like a macro scale question. So this is actually a very famous question, that can we do incentivization and decentralization in permissionless blockchain at the same time? This is actually a very famous question because Silvio Micali says incentives are the hardest thing to do. And this May, Vitalik talked about, we need some kind of radical decentralization because all these blockchains are becoming centralized. So, what we mean by decentralization? So, we want to have the number of players as large as possible, right? And we want to have somewhat even resource power. So we want to have some kind of even power distribution. You may ask why the resource powers are not even, but why do we want to have them? It's because when you look at, for example, mining pools, like a few mining pools have, huge computational power, and it's very, very centralized, right? People, already there are papers showing that Bitcoin and Ethereum is actually very, very centralized, okay? Because resource power distribution is not even. So then, can we design incentivization system that can reach this kind of ideal decentralization? And basically we are finding some of the requirements. To make such decentralization possible, like nodes with any resource power should earn some profit, right? Any resource power. Right now in Bitcoin, for example, someone without any resource power will earn nothing. I mean, with very small resource power, nothing. Because of that, they are joining the mining pools, right? And also, it should not be more profitable to delegate their resource to others than the case that play run nodes by themselves. Do you agree? If you start delegating, then you might have problems. And also, the second requirement is that it is not more profitable for one player to run multiple nodes than the case that the player runs one node, right? In some cases, actually, people are spreading their nodes. In case of, for example, in case of EOS, suppose someone is really rich. Okay? Suppose someone is really rich, then he should be actually spreading his power to many different nodes, right? Then he can actually take all those 21 nodes, right? And it is actually more profitable, right? And the resource power ratio between any two nodes converges in probability to 1 is the last question, that actually we want some kind of pretty well-balanced world to maintain the good decentralization. It should not be 1, but could be maybe 2 or 3, some reasonable numbers, right? Is it possible? So these are the 4 requirements we come up. And if we actually satisfy these 4 requirements, we probably can reach full decentralization. Now the question is there any incentive mechanism or permissionless blockchain satisfying these 4 conditions? Have you seen those? Or did you think about it? I was talking to Jay Cohen yesterday, and some of them have some ideas. And we are actually, my student has analyzed top 100 cryptocurrencies. And out of top 100, about 68 are either POW or POS or DPoS. And out of 68, there was no coin that satisfied all those 4 conditions. So the black circle is the satisfying the conditions, but actually many of them are not satisfying. Most of the actually POW or POS actually does not satisfy the condition 2 and condition 4, and in case of DPoS, they are only partially satisfied. So let's go back to Mikhail's question. Mikhail says, people ask Mikhail, right? Can you say anything about incentive in Algorand? Because Algorand did not have any incentive mechanisms. And Mikhail says incentive are the hardest thing to do. And we actually prove that it is impossible to design such incentive systems. So meaning that actually in the permissionless blockchain, the incentivization and the decentralization is a dilemma. That if you try to incentivize users, your network will become centralized as it is by being the most of the other blockchains. Unfortunately, we don't have the paper ready to put online yet, but probably I think sometime around 20 to 1 month, we're going to post a paper about our mathematical proof and all those measurement study about top 100 coins. And of course, there could be errors in the mathematics proof, and we will get some opinions from the experts first, and after every expert says it's fine, then we'll be posting the paper online. And then you can check, if our paper is correct. So let's just go back because I have some time. Oh, okay. So again, what we prove is that if you try to incentivize permissionless blockchains, then your blockchain will become centralized, like Bitcoin or depots and every other actual coin. Yeah, 3 minutes, good. So this is my conclusion slide. So I still think, theoretical and experimental evaluation is important. And because many of the blockchains are the public blockchains, so you can join the public network and you can actually measure properties such as network, voting, robustness, scalabilities, and products, producers. All this information is available. The thing is that we are not comparing technically between each other. And also, we are developing BLIP for emulation and evaluating platform for blockchain and also for education. And also, I talked about incentivization and decentralization dilemma, and probably the paper will be out pretty soon. And we've been doing other works like, Bitcoin mining, which is, so Bitcoin mining paper is asking this, right? So between the Bitcoin and Bitcoin Cash, actually, some miners were moving between these two, right? Because when there is when the difficulty becomes easy, people were moving between these two. So our question was, if people move between these two continuously, automatically, by looking at the value of the coin, then what's going to happen? So our answer is actually Bitcoin Cash is going to die. If 10%, if the ratio is, okay, so you can look at the paper later. Yeah, anyway, so that's it. Thank you very much for your attention. And if you have questions, I can take just one quick question. And I can take it offline, yes.
Hi, thanks for the great talk. I was just curious, what's your personal takeaway from the dilemma? Do you think it's more likely that projects will give up incentivization to hold decentralization, or vice versa? And in what case?
Yeah, so actually more precisely, what we show is that unless you can charge more to the civil attacker. So if you split so for those people who split their account, they should pay more. If you can enforce such mechanisms, then probably we have some hope. Or in the other way, actually, we say it is impossible in a permissionless blockchain because if there is actually trusted identity management, so if there is some kind of probability that, okay, this account just belongs to one account, or if someone makes multiple accounts, then you can actually detect, oh, this is from Yongdae, then, yeah, maybe. But if you have identity management, complete identity management, that's not anymore permissionless blockchain, right? So somehow we need to increase the cost of the severe attacker, and I don't see any way to do it for now. So that's a difficult question, I think. Yeah. All right, thank you very much, and if you have more questions, I can talk to you outside. Thank you.